So you want to show me your conversion, how you're going to do your converting. I want to see your unit analysis is what we call it. You've done unit analysis, I think, in chemistry. So you should be fairly familiar with this. Degrees are in degrees. There's 360 degrees in a rotation. There are minutes and seconds. All right, so it might be 30. Ugh. This is not working. There might be, I might give you something that says a rotation of 30 degrees, 25 minutes, and 16 seconds. You're going to want to put that in your calculator, and it's going to be in a decimal. And I want to show you how to do that. All right, so in normal time, in a normal clock, how many seconds are in a minute? All right, so that we know that there are 60 seconds equals 1 minute, and 60 minutes is going to equal 1 degree. That's your conversion. So I'm going to check to make sure that you're doing this how I want you to do it so that I know you're getting your units right. I don't just want to see the math, I want to see the canceling of the units. So 16 minutes is what I'm converting. And we want to convert it to seconds. And so I know that my seconds are the unit that I want, and therefore they go up in the numerator, yes? And the unit that I don't want is what goes in the denominator. Now, if there are 60 seconds in 1 minute, where does my 60 go? Does it go in the numerator or the denominator? Yeah, because 60 seconds in 1 minute. It's not 1 second for every 60 minutes. Show me the canceling of your units. This is strictly a multiplication problem, and you get 960 seconds. You're just multiplying your fractions, yes? All right, 3 hours to minutes. Well, 3 hours over 1 times minutes over hours. Again, 60 minutes in an hour gives me 180 minutes. Cancel those units. So the decimal degree measures can be expressed in degrees, which has this little symbol, minutes, which is a single tick, and the double tick are your seconds. Okay? So convert 12.520 degrees to minutes, minutes, and seconds. Well, we know what the degree is. What is the degree? 12. We know we're starting with 12 degrees. The problem is what to do with this decimal portion. So what we do is we take 0.520, this is still in degrees, and we convert it to which one first? Minutes. And what is the conversion from degrees to minutes? 60. So we're going to multiply by 60 minutes over 1 degree. We'll get your calculator out. Because we talked about it up here. 60 minutes equals 1 degree. Well, because I want this clean. I have 12.520 degrees. So I know I have a full 12 degrees, and the 0.520 is what I'm converting into my minutes and my seconds. Does that make more sense? All right. What do you mean you don't get what degrees is? There's my degrees, because it's the whole number portion. This is also degrees, but it's a portion of a degree. So how many minutes and seconds is that making up? If I give you 13.5 hours, wouldn't you say that that 0.5 is 30 minutes? That's all I'm doing. You can think about it like I have 12.52 degrees. That means I have 12 degrees. Well, how many minutes? That 0.52 is how many minutes and seconds? Does that make sense? Just think about it in terms of a clock. If I have 2.5 hours, 0.5 hours is what I'm trying to convert into my minutes or my seconds, the decimal portion, okay? All right, so what is 0.520 times 60? 31.2. This is in minutes, right? So I have 12 degrees, and how many minutes clearly do I have? 31. So now I have in 31 minutes. What am I going to do with this 0.2? Turn it into seconds. Right, my decimal portion is what I'm converting. So I have 0.2, but now my 0.2 represents minutes as my unit that I've left in, right? Take that over 1, multiply it by, I want it in seconds and get rid of my minutes. There are 60 seconds in 1 minute. Units are canceling. And what is 0.2 times 60? How much? 12 seconds. So I have 12 degrees, 31 minutes, and 12 seconds. Now let's write this appropriately. 31 degrees, no, sorry, 12 degrees, 31 minutes, 12 seconds. This is the same thing as saying 12.520 degrees. Allie? Yes. Yes. We're not going to do that, though. We're simply going to work with 30, 60, 90, 45s and the quadrangles. Mm-hmm.
Is this converting it to degrees, minutes, and seconds?
Is it converting it to degrees, minutes, and seconds? Look at your answer.
Well, I think like both.
Okay? All right. As I'm telling you that. I told you that at the very beginning. All right, here we go. Now we're going to go backwards. I'm saying I give it to you in degrees, minutes, and seconds, and I want it just as a degree. When I say rounded to the nearest thousandth, I'm saying converted just to degrees. All right. Well, I know that I have 24 point something, right? Correct? Well, what do I do with my 15 minutes? I need to convert it into a what? Well, what's my conversion? I got to go minutes here and degrees here, correct? 1 over 60. All right. Well, what is 15 divided by 60? Notice that I said nearest thousandth. That means how many decimal places? Oh, my gosh. Who said 1? Tenths, hundredths, thousandths. How many decimal places is that? 3. What is 15 divided by 60? Just 0.25? Okay, there we go. That's so that now. So I've converted, I know that this is 24 point. This is 15 degrees, which is 0.250. How do I do 22 seconds into a degree? Turn it into minutes. All right, so how many minutes in a second or seconds in a minute? 1 over 60. That takes me into minutes, but is that all I need to do? Take it into degrees. So again, 1 degree over 60 minutes. So I'm taking the 22 and divided by 60 twice, or 3,600, yes? To the nearest hundredth or thousandth, what is that? So I have 24 degrees plus 0.250 plus 0.006. Therefore, 24 minutes, 24 degrees, 15 minutes, and 22 seconds is the same thing as 24.256 degrees. Is this going one way or going the other way? It's just a conversion.
Oh, so you can do the minutes and degrees the same.
Mm-hmm. Okay. How we doing? Debbie, you okay with the stuff now? Well, we want to work with everything in degrees. a rotation. So if I said 24.256 degrees from 0, I'm moving it, you know, what is that rotation going to give me? How it relates to math? Oh, well, 20, you know, think about your clock. One rotation is 360 degrees, right? But how many times is it, right now, I don't know how many times it's rotated, but it's rotated so many minutes and a few seconds also, right? So I can figure out that full rotation just in terms of degrees. Okay. We'll be doing some clock problems. Kind of help you. All right. So an angle can be generated by rotating a ray multiple times around the origin. All right. Here's your origin. Rotation can be positive. A positive rotation is a counterclockwise rotation. Starting at the origin, which is 0, rotating it this way is a positive rotation. Starting at the origin and going clockwise, which is counterintuitive. We want to think of clockwise being positive, but it's really, that's the negative. So rotating your ray downward is a negative rotation. 0 is always here. No matter which way you're rotating, 0 is here. All right? This is called quadrant 1. This is called quadrant 2. This is called quadrant 3. This is called quadrant 4. All right. We want to show 2.3 rotations clockwise. So we've gone around 2 full times, yes? So we start by doing our XY axis. Clockwise. So that means I start here. Which way am I going to go? Up or down? Clockwise is down. Here's one rotation, right? Start to finish, correct? And how do I show another rotation? Well, I go around again, yes? So there's my 2 rotations, right? But I need to do the 0.3. So remember, we got to take that 0.3. It's 0.3 of one full rotation. How many degrees is in one full rotation? 360. So 0.3 times 360 is what? 108 degrees. So I have to go another 108 degrees. Now, I don't need it exact, but would you agree that when I'm going clockwise, this becomes my 90-degree reference, correct? And this becomes my 180-degree reference because I'm going down and around, right? Where is 108 going to fall? Right here, isn't it? Down here on the bottom. It's after 90, but before 180. So we're going to put it someplace right here. And you put your arrow showing me the rotation that we went around clockwise. That's your answer to your problem. You've showed me 2 1/3 of a rotation. All right, 4.2 rotations clockwise. So clockwise means we're starting here and we're going, sorry, counterclockwise. So here's 1 rotation, 2 rotations, 3 rotations, 4 rotations ends me here, but how do I figure out the 0.2 part? 0.2 times 360 tells me what? 72 degrees, right? Where is 72 going to fall? In quadrant 1, someplace right here. Put your little arrow and you're done. Again, I don't care where you have it fall. I mean, try and make it accurate, but other than that, it's fine. So non-quadrangle angles is an angle greater than 360 degrees. Okay? The reference angle is an acute angle. What's acute mean? Less than 90 degrees. So again, everything's coming back to that 30, 60, 90, 45. All right? Which you're going to have to memorize. But for today, those aren't going to be my only answers. But acute, less than 90. And look what I said. You reference it with respect to the x-axis. Do not use that y-axis so many of you are going to want to do it, and you're going to get it wrong. It's going to give you the wrong answer. It's the x-axis. Okay? So let's look up here. Let's not look up here. So here, let's go to the next page. Find the measure of the reference angle for 220 degrees. All right, this is a positive rotation, correct? This is 90, 180, 270, 0, and 360. These are your angles. Where is 220 going to fall? In the third quadrant. So we're doing this, and we're going to extend our ray. Our ray is rotating and ending up in the third quadrant. Now, I want to know what my reference angle is. So remember, how many degrees did we go around? So we're at 220. What does my reference angle have to look like? A value less than 90. So where did I say you take this with respect to? Which axis? X-axis. Take this and look and draw your little triangle up. This right here with respect to the x-axis is my reference angle. That's where I find it. How am I going to find it? What is that degree? What is this little bitty rotation here? 220 minus 180 leaves me with 40 degrees. This is my reference angle. Because I got to go past 180. 180 is that horizontal axis. I've gone 180 degrees plus how much to get me to 220? 40 degrees. Do not use 270. Wrong answer. Okay? All right, find the measure of the reference angle for 640. Well, how many rotations is 640? Well, we can subtract 360, right? And what do we get? 200 and... All right, so we know that we're going to go around once. And where are we going to end up at if we're going to do another rotation of 280 degrees? In the third quadrant? In the fourth quadrant, right here, right? Just a little bit past 270 degrees. So we're going to draw our little ray, because that's where it's ending. And where do I draw it to, my triangle? Up. It's got to be drawn to the horizontal axis. Well, the horizontal axis is what? Either 0 or 360. So I'm looking for this little bitty rotation. How do I figure out what that is? 360 minus 280 means my reference angle is 80 degrees, because that's the degree that takes me to the horizontal axis. Yes. Because we know that in one rotation, that's 360 degrees, right? So 640 minus 360 means I've got to show a rotation of 280 degrees still, so that I go a total of 640. So one rotation takes me here. Another rotation for 280 takes me in the fourth quadrant. Allie? Uh-huh. Uh-huh. Yeah? You may not. Because what is 0 going to do? You're not going to get your little reference angle. Hold on. Determine a coterminal that's between 0 and 360 and state the quadrant. Same idea. This one is negative 995. That means I'm going around once, twice, and you're going to end up at, how many times? Once, twice, 3 times. And you're going to end up here with this value being 85 degrees. So you're adding 360, right? You don't want to subtract 360 because that just makes it more and more negative. You following that? Okay. The rest of these notes are online for that one. Okay. All right. Have a good day.